Right, so this is me over on the left-hand side. The slides that you're seeing here are available for download. They're on SlideShare. There's a URL for you if you're interested. I am an information architect at the IBM Hursley lab. Hursley is a software development lab. That means it's not a research lab. We don't get to play with scanning, tunneling electron microscopes, nor do we get to play with those fantastic atom lifters to create animations. We write software. The Hursley lab creates a number of software packages. If you've used an air traffic control system, in other words as a passenger on an aircraft, if you've used an ATM, then you've been using some IBM software called KICS, Customer Information Control System. That is developed totally within the Hursley lab. My particular area is the Java Runtime lab part of Hursley. What we do is to develop IBM's implementation of the software development kit for Java. In other words, we don't create IBM Java because Java belongs to Oracle. We create IBM's implementation of a software development kit that complies with the Java standard. As the information architect, my responsibility is to create product documentation which corresponds in this case to the Java software development kit. Excuse me. Disclaimer on the right hand side, yes, I am an IBM employee, but everything that I'm saying here today is my own particular opinion and collection of ideas. So, what am I going to be talking about? Some concepts to begin with. By information development, I mean the idea of creating content that is used by people to understand how to use a product. Reference guides, user guides, that sort of thing. Am I or my colleagues technical writers? Possibly, but if you've done any work using DITA or DocBook, you know that quite often it's unusual to even write a complete sentence. Certainly when you're using DITA and you've got conrefs and the ability to use macros within the XML, then you can start to get some quite tortuous XML markups, so you very rarely write an entire paragraph. So information development is about creating readable, usable product information to go with, in my particular case, software products. The interesting thing for me about information development at the enterprise level, in other words, what are the enterprise documentation characteristics, are things like a requirement to be able to translate the documentation. We have to make documentation available in all markets. As a simple example, if we want to sell products or services within Canada, all of the documentation and indeed the onboard help for products must be available in French and English at GA date, otherwise we're simply not allowed to sell or market in those in that particular country. So translation is very important. Accessibility. There is an EU directive being discussed at the moment which is going to make it compulsory that any information you make available to customers must be usable by people with, let us say, visual impairment or something like that. So enterprise documentation means that writing docs with Word is insufficient, because it's a real pain trying to translate, it's a real pain trying to get it all accessible. We have to do something else, and that's why we use XML-based documentation. What do I mean by an information set? I mean a collection of files which, when aggregated together and built, pass through some sort of munging engine, will produce some readable, consumable output. What format would that have? Possibly a web page, XHTML, almost certainly PDF, EPUB format, MOBI format, all of those kind of things. So an information set is a set of documents that are usable by you in some form. An information stream is a different way of slicing that. The information stream concept will become clearer on the next slide. Or two, but basically what we're talking about there is a line of development for a collection of information files, but it will become clearer shortly. Darwinian information typing architecture, I won't say too much about that. It is simply an XML-based markup language. So, well-formed, valid XML that happens to contain content that can be converted into web pages, PDF, all sorts of other formats as well. And finally, I get to the theme of the talk today, distributed version control system. I will define this in a bit more detail later on, but in essence, a version control system says, here are a collection of files. Let's say there's 20 files, and I'm going to be modifying one of those files. So I make a change, and I want to save that change in such a way that I can easily roll back to the earlier versions. Because just one change, that's easy, I can remember what I did. But 20 changes, 200 changes, if I want to be able to roll back to those previous versions, how can I do so? A version control system will let me do that. The interesting characteristic of a distributed version control system is that it is distributed, and I'll explain what that means in a little bit of a couple of slides. So those are the definitions that we need to be working with for the moment. So here's the slide that I hope helps to explain what I mean by an information stream. Think about each one of these blobs as being the collection of documentation files. So I might have an introduction file, I might have a getting started file, I might have an installation file, I might have a large number of files explaining how to troubleshoot the product, that sort of thing. So blue blob, top left hand corner there, that's a collection of files. And I make some changes. Maybe there's some modifications to the installation process or some new features coming in on the command line, something like that. That moves me to the second blue blob. And that's what I mean by an information stream as opposed to an information set. An information set is any one of those blobs. An information stream is the logical flow as files are being updated and enhanced and generally improved. Now the blue dots I've labelled the original version. What I mean by that is this is the master collection of documentation. So if at any point I decide I want to have the user guide for IBM SDK for Java version 6 on the AIX platform, doesn't that just trip off the tongue, I would simply go to one of those blue blobs, hit the print button, virtually speaking, and out will come several thousand pages worth of documentation. So that's the original version, that's the business as usual documentation. Every so often, as a product is being developed, something interesting happens, and that interesting thing might be a completely new platform. So a new piece of hardware comes along, or a new operating system, or something exciting like that. So what we'd like to do is to perhaps extend the documentation to accommodate that. Now if you think about it, for almost any product, the basic concepts, what the product is, how it works, what you can use it for, that'll remain the same. The basic functionality, that'll remain the same. But for a new platform, the installation might be very, very different. So if you're installing a package onto Windows, that's very different to installing onto AIX, which is very different to installing on ... So what we would do is we would start a completely new collection of documentation. But we don't want a completely new set of documentation files. We only want to change those files that need to be changed. So the green blobs represent, in this case, changes probably to the installation files. All of the other files remain completely unchanged because they don't need to change. At the same time as this new platform's coming in, there might be a grand strategic decision to say we're going to have a brilliant new command line feature, XMagic, and when you use the XMagic option on the command line, what you get is an 80 times performance improvement, that sort of thing. Wonderful new feature. So that's down here at the bottom in red. So we've got our main line documentation set. We have some additional changes for a new operating system, new platform, whatever it might be, and we've also got a new feature coming in as well. Now, for various reasons, we may or may not decide to actually ship this new operating system. or we may decide not to ship this new feature. Perhaps when we hit the magic button, we find that it doesn't get us our 80 times performance improvement, it's only 79 times, which is nothing like good enough as far as marketing is concerned. So what we have to do is to say, right, we'll go back to the drawing board with that, we'll continue working on the development of it, but it's not going to ship yet. So, the new platform might be merged into the documentation, the new feature might not. So it's a hypothetical scenario. The problem is that all the time, all of these documentation sets are being updated, and they could be updated by people all around the world. We have documentation teams quite literally all around the world: China, India, Canada, US obviously, here in the UK. So they're all trying to interact with these documentation files. So we've got lots of people trying to use the same files at the same time, potentially, doing different sections of work. Sometimes it's a very simple little defect. Somebody left a full stop off a sentence or something like that. That would be a simple change that goes into the original version. Or it could be a major piece of work here, which is going to take, if not weeks, then possibly months of work. How are we going to make sure that the mainstream business as usual work can be done at the same time as all of these major activities? I won't go into too much detail about this. This was for people who aren't familiar with Ditta, or to a lesser extent DocBook. On the left-hand side, you have the idea of a Ditta map file. This is very, very simplistic. It's actually taken from the Ditta Open Toolkit. The key point is it's a simple XML file that describes the structure of the overall documentation. You can see here, I've highlighted in bold, exploring the Ditta ot.ditta. That's a reference, a pointer to the file on the right-hand side, which is another XML file containing some content. In this case, it's an explanation about getting started with the Ditta Open Toolkit. So if you haven't seen Ditta or haven't worked with DocBook, that's the sort of bread and butter material that we're working with on a day-to-day basis when we're doing information development. Key point to take away from this, you can read it. It's text-based. Within IBM, all of our documentation is written in English, strictly speaking American English, and it would then be translated if required. So this is exactly the sort of thing that you would expect to see if you're talking to an IBM information developer. So, let's talk about distributed version control systems. I promised that I'd be defining them in a bit more detail. A version control system lets you store different versions of a file, and all of those versions are stored in a central repository somewhere. So if you've got 10 developers, and they're usually software developers, programmers, they would all access this central server, and when necessary they would bring down a copy of the files, make some changes and push changes back into the central server. The thing about a distributed version control system is that you don't have a single central repository. Everybody has a copy of the entire repository. You all have every single file. Now, you might think that is insane, but I'll present a few numbers in a moment which suggest that actually it's not quite as mad as it might appear. So everybody has a copy of the documentation set, the complete repository. You can all roll back as far as you want, and crucially, you can create a new branch. You can say, I'm going to be working on the documentation for this new operating system or this new feature. And you can do that because you have a copy of the complete repository. You've got everything you need to work independently of everybody else. If you choose to share those changes, your local changes can be shared to other people. So if you decide that the work you've been doing on the operating system is great, it's good to go, it's ready to be merged in, you can share your changes with everybody else and they can bring them into the mainstream documentation. The problem is, how does the sharing actually work in terms of integrating into the main documentation? And this is the problem of merging. Now on the right hand side here, what you're seeing is an actual snapshot from a real project. I won't name it. I do work on several projects other than Java, so you shouldn't assume that this is anything to do with Java. It's an actual snapshot from a distributed version control system called Git. Git, created by somebody that most of us will have heard of, a certain Mr. Linus Torvalds. What I did after I invented Linux, basically. So this is a graphical view of the Git repository for this particular project. And crucially what's happening is you can see lots of different branches which are being merged in as required. Now the interesting thing about the merge is that within Git it is handled automatically for you. And what we would like as far as DITA is concerned, in other words as far as XML is concerned, we want the merging to be as automatic as possible. So if I've got two versions of an XML file, I want to ensure that as they are merged, what I end up with is still a well-formed and valid XML file. A difficult but separate problem is whether that content still makes sense. And from that point of view, I'm talking about the semantics, the meaning. There are certain little tricks that we can apply here, and without going into any detail whatsoever, I will just mention a teaser phrase, which is the idea not of test-driven development, but test-driven documentation. That is something that we have been using within IBM, and is one way of approaching a solution to the problem of ensuring semantic continuity, as well as ensuring that we've got a valid, well-formed XML file. If it cannot do the merge, if the DVCS system can't merge the files successfully, then we would like it to explode very, very noisily. We really do want to know that something quite bad has happened. And the reason for that is because if it was quiet, if it kept it secret, then we're going to find out eventually anyway, because when we do a build, it'll fall over. The PDF generation process will say, I do not understand what that XML markup is because it's not valid, it's not well formed, go away and start again. So we want fail gracefully if it can't do the merge. And by fail gracefully, I mean it should put up its hand and say, I'm not having this, the merge has not succeeded. I promised some numbers, and here they are. We, on one particular project, again it may or may not have been Java, on one particular project we were using Subversion, which is a version control system, as the repository, and the way that that works is a central server, and that repository took about 800 megabytes, something like that. When you were locally working with a copy of the files, you would download the current snapshot, and the way that that works is you actually have two copies of it. One is the definitive working copy of the snapshot, and then you have your local working copy of the file, so you actually get twice the storage requirement, which is a little bit tedious. So we found that for any given snapshot, any given download of the repository, it was going to be taking about 1.6 gigabytes of storage. That's a fairly average sort of size. When we were migrating this over to an alternative storage system, I was experimenting with Git as the DVCS. What I found was quite interesting. The server copy of the entire repository was considerably smaller, 331 megabytes, probably because the vast majority of files are duplicated. They don't change from version to version very much. So we're getting massive benefits in terms of compression and reuse of files, only about 331 megabytes there. But what was really interesting was that the local copy, in other words the one that you work with, was only 1 gigabyte. Now that's significantly smaller than the 1.6 gigabytes if we were using Subversion. But crucially, in the Subversion copy, I've only got the most recent snapshot plus my changes. Whereas in this, I have the complete history of the entire project, which is fabulous news, because it means that I can look back through the complete history of the project, even if I'm sitting in an aircraft at 30,000 feet with no network connectivity at all. Or even better, I'm from the south coast and live in Warman, so I could be sitting on the beach getting, if not a suntan, then at least rain burn, and working with files at the same time. 5 minutes, gosh, right, I've got to go quickly. So, if we use the DVCS, what does that let us do apart from work with all of these wonderful branches? Well, here is a slightly extrapolated example, but I can assure you that I've done some simple tests and it does actually work, which is quite fascinating. So we have some files in our common origin. That's our starting point. And within that we identify our common content branch. So these are the materials that are common to all of the different documentation releases. It could be the overview, the reference guide for messages and diagnostics and troubleshooting, all of that sort of thing. And then we have separate streams, information streams, remember that from the definition up at the beginning. It's separate streams which talk about, in this case, platform-specific content. So if I'm wanting to produce an information set which is talking about product X on the Windows platform, then I would need to have the common content branch and the Windows specific content branch, and I'd like to merge them together to produce a Windows release branch. Now the amazing thing about when you're using Ditter is you can actually do that, because these files are either completely separate from those files, or they have sufficient points of commonality that you can merge them. And as long as you have a reasonably safe merging process, you've got a pretty high level of confidence that what you're going to end up with here is going to be valid. As an additional check, within the Git infrastructure there is the concept of porcelain and plumbing. I won't explain what they mean, other than to say that they are mechanisms for you to extend the Git engine. So what you can do is, as you check files into Git, you can run a sanity check, and that's exactly what I do. On my Linux box I use a very simple little tool called XML lint. Anytime I try to push any merged content into the repository, XML lint will ensure that the files are well-formed and valid Ditter markup. And in fact that's been fantastically useful, because on very odd occasions I found that some of my colleagues who will remain nameless have actually been editing files directly using Notepad, and they've left off a bit of tagging and marking, and that's going to cause all sorts of nasty pain. But when I try and check it in, XML lint says, oh no, hang on, this is not valid, so I can go and beat up my colleagues, which is enormous fun. Okay, so that's DVCS, how we can use it for multiple deliveries. Very, very quick summary, advantages and disadvantages. It's not a content management system. I'm not attempting to use a DVCS as a way of properly managing content from the information development point of view. In other words, it's a mechanism for looking after files that happen to contain content, but it's not a replacement for a proper content management system. So if a technical writer were in the audience, they would be having palpitations at the idea of using DVCS for something like this, because they are assuming it's going to be good quality content management. No, it's not that at all. It is possible to have mechanisms for ensuring validity of markup, mentioned that. Reuse is possible, we talked about that by merging different branches. You could take that to the extreme, where the common branch is almost empty, and you're bringing in, assembling different documentation components, almost like Lego bricks. That does work as well. Assembly of content on demand, fascinating. The downside of this is multi-branch management can become very complex. We've seen some very, very simple diagrams. Within the IDK for Java documentation, we could, in theory, have many, many permutations of documents. And in fact, under the worst case, the pathological case, we could actually, from one file, generate 19,000 different variations of the documentation. Most of them would be completely meaningless, so we don't go that way. 1 minute, I'm going fast. I've got to go faster. Do local requirements, local storage requirements scale? I think so. We haven't yet found an instance where the documentation goes too big to handle, but that's something to keep an eye on. We're certainly going beyond the intent of the original DVCS content, but hey, that's what experimentation is all about. One problem area is moving subcontent. So a small section of a file moved into another file can sometimes make the Git merge tool a little bit upset. So we do need to do some refinement in that area. Final slide. I've talked about basic characteristics of enterprise documentation. It's very, very similar to enterprise software development, so we're borrowing some of the tooling from there. We've been able to apply DVCS to some challenging documentation tasks. This has actually made life a lot easier for us for certain specific problem scenarios. But it's still experimental. I'm not saying this always works under all conditions. I'm saying that we found some really interesting situations where it has worked for us. It may be that it might work for you and would be worthwhile having a look at. That's it, I'm done. Apologies for going so fast. Thank you very much. Thank you, Adrian.
Do we have any questions?
Yeah, Stefan?
Yes, it's a question about the, maybe not focused on what you say, but it's context. To produce this content, which is it documentation about software?
What I work on is yes, but the basic mechanisms in terms of using DITA and our build processes are applicable to hardware as well. But the whole point about the enterprise documentation process is that it should be as generic as possible. The moment you become specific to software or even a product within software, it becomes very, very difficult to scale up for translation purposes, for example.
Because I wanted to know, in the case of software documentation, if you have some mechanism to, because you use also some software depot for the code also, if you have some mechanism to link both of them.
Yes, yes, yes. There are a number of connections that we can have. So, for example, we have extraction tools, again in the Java area, as software developers are producing the Java runtime, they will have error messages, and so we have tools that go into the Java source code, extract that, convert it into DITA automatically, so that our build processes will say, here are the error messages. Sorry, never any error messages with ID in Java, very, very tiny. But yes, we do have tools to handle that.
DITA has filtering mechanism, DITA files.
Yes.
When do you decide to use them? Do you use them as an alternative to branching or in addition to branching?
Oh, yes. We would use those. We would use those for production ready once the branching has been. Okay, start again. Supposing we want to prototype some new documentation, we're not quite sure how to make it work in terms of the content or the DITA val filtering. That's where we would use the branching mechanism there to try it out, to update it. Part of the process of getting it back in, merged into the mainstream is to say, okay, we now have this operating system version, the content is good, we know that it builds, therefore we can include the appropriate settings in the DITA val. So we're able to, if not discard the branch because we've integrated it, we can say it is no longer required because it's part of the mainstream.
Do you also version binaries, screenshots, or other images maybe?
I do, and the reason is because it's as easy to include them as not. In other words, if the binary image hasn't changed, then it's zero cost as far as DVCS is concerned. If it has changed, then you probably want to be able to have the different versions anyway. But certainly with binaries, you're not going to get the efficiency of compression that you do with text files.
Yes, it's great using DVCS for other things that it's intended for. The hallmark of a good technology is how one can abuse it.
Yes.
But have you considered other solutions? I mean, there are databases out there that have point in time, you can save every version of the document. Is that something that you've considered, or is this a tactical solution that lends itself to your publishing process? Or
I wouldn't even give it the grace of calling it a tactical solution. It was more, we have certain challenges. What zero cost approaches do we consider? In other words, I fancied having a play.
Are you using like post-commit hooks and all that? Or,
That's exactly right, yes. Post-commit hook for the XML, yes.
I think to reply to that, actually one of the obvious answers is you need Git for other things anyway, so it's saving you running another system. I mean, that's the major advantage why I use it in a similar situation, because
Yes.
it's around anyway.
Yes, I'm going to be very careful about what I say.
But that can cause big problems because you're using the same system for many things, and there could be different consumers, different users with different ideas about performance, quality of service, etc.
Being careful about what I say. There are appropriate solutions and there are experimental solutions.
Any other idea, people?
George.
There is also another interesting approach with DITA for versioning. the guys from SAP presented that a couple of times, I think. They are using actually keys, the new key support in Data 1.2. So basically we have indirect resolution to topics, and then when they want to create a new version, they clone the mod, and they just they create new topics, let's say for 2 of the topics, and they change the keys for only for those 2 topics. So basically, all your changes then will match only the incremental changes to the documentation. The rest is reused automatically through this.
Yeah. Oh, there are many ways of approaching the problem, no doubt. One of the things I wanted to do was to experiment using DVCS. As I say, it was a self-indulgence, really. I wanted to see how DVCS could be used for a day job, i.e. using DITA, but I think this would probably work just as well for DocBook or any other kind of markup as well.
And another idea would be if Data XML will look into, you mentioned that sometimes you may get some issues with merging. So maybe you can try to integrate that
We're
with
certainly looking at this problem and solving the problems with conflict. Possible, the problem you see with possibly superfluous or false conflict you find when you do merging. And it's an active area of product development.
Absolutely, yes.